Right now, your computer is silently preventing, I mean, literally hundreds of catastrophic collisions every single second.
Mm.
You don't see it, and you certainly don't feel it when you're, just scrolling the web. But under the hood, your keyboard is fighting your graphics card from memory.
Oh, yeah.
Your network connection is demanding CPU priority, and your hard drive is trying to talk to all of them at exactly the same time.
Right, it's chaos.
It is. It's total chaos. And if left to their own devices, your physical hardware components would basically just crash into each other instantly.
Yeah, the whole thing would just lock up.
Exactly. So, today's mission on this deep dive is to explore the invisible foundation that stops that from happening. The operating system, or OS. We are pulling from some deep industry-level IT certification frameworks to really decode how the biggest tech giants in the world, Microsoft, Apple, Google, and, the open source community, how they approach building these digital foundations.
A huge topic.
It really is. We are examining the massive trade-offs they make between, hardware freedom, walled gardens, and cloud minimalism.
To a daily user, the operating system often just feels like, I don't know, the background wallpaper.
Right.
A taskbar, maybe a start menu.
Right, it's just the stuff on the screen.
Exactly. But beneath that graphical layer, it is doing an unbelievable amount of heavy lifting. It's the essential link between the physical hardware you paid for, like the actual metal and silicon, and the applications you actually want to run.
Yeah, I like to think of the OS as sort of like the ultimate city planner, or maybe a really stressed out traffic cop, managing a chaotic intersection.
That's a great way to look at it.
Because it handles all the messy input and output completely behind the scenes. But here's the question that kind of drove me into this research. If the OS is essentially just a traffic cop routing data, why does it matter so much which traffic cop we hire?
Well, it matters deeply because the choice of that traffic cop dictates your entire digital ecosystem. It isn't just about routing traffic. It's about setting the fundamental rules of the road. Your OS dictates exactly what hardware you're even allowed to plug in, what level of security vulnerabilities you're exposed to, and ultimately, what applications are permitted to run in your city.
Wow, okay.
Yeah, you can't just, take a software truck built for one city and drive it into another if the roads are paved with a fundamentally different underlying code.
Right, the infrastructure is just totally different. Let's take that city planner analogy and look at the biggest metropolis on the map. Because if we want to understand OS scale, we really have to start with the ubiquitous juggernaut, Microsoft Windows.
Right, the big one.
The big one. This is an operating system built on a very specific philosophy, which is massive hardware support. Windows is essentially the mayor of a bustling, chaotic, totally open public market where anyone can just set up a stall.
Massive is almost an understatement here. Windows is designed to run on a nearly infinite permutation of hardware. You could build a custom desktop computer out of 1,000 different combinations of motherboards, graphics cards, network adapters, from dozens of different manufacturers.
Right, just totally piecemeal.
Exactly.
Yeah.
And Windows is expected to just figure it out and boot up. And because of that massive market presence, it enjoys unmatched industry support. Practically every developer writes software for Windows because, well, that's where the most users are.
But being the biggest city with the most open borders, that makes you the prime target, right?
It does. That is the dark side of market dominance. There's a massive global network of attackers dedicating all their resources to finding vulnerabilities in Windows.
Just because it's the biggest pie.
Simply because hacking a Windows machine gives you the keys to the widest pool of victims. But beyond malicious attacks, Windows has an inherent operational challenge, which is driver compatibility.
Yes. Okay, I want to pause on drivers because that is where the whole open market philosophy gets really messy. A driver is essentially a translator between the operating system and a specific piece of hardware, right?
That's exactly it.
Like, Windows doesn't inherently know how to tell a specific HP printer to fire ink onto a page.
Right.
HP has to write a tiny piece of software, the driver, to translate Windows command to print into the specific voltage pulses that printer head needs.
That is the perfect way to describe it. Microsoft doesn't write the translator for every random printer or webcam or network card. The hardware manufacturer writes it.
Okay.
And sometimes those manufacturers write sloppy translators.
Which causes problems.
Huge problems.
Yeah.
When that translator feeds garbage data to the core of the operating system, the system basically panics to protect itself.
So when your Windows machine suddenly gives you a blue screen of death and crashes, you usually curse Windows.
Oh, absolutely. Everyone blames Windows.
But often it's actually a third-party hardware driver failing to communicate properly with the OS.
Exactly. It's the translator's fault, not the mayor's.
Right. And we see Microsoft trying to modernize and stabilize that metropolis with the shift from Windows 10 to Windows 11. They finally dropped support for 32-bit CPUs entirely.
Yes, that was a huge shift.
It is strictly a 64-bit OS now, which fundamentally changes how much memory the system can address. Plus, they added deeper Teams integration, they introduced snap layouts to manage your screen space, and they are heavily pushing their Copilot AI.
Yeah, Copilot is everywhere now.
It really is. But despite Windows 11 being the current standard, businesses are notoriously stubborn. The official end of life for Windows 10 is October 2025, but I bet we see companies running it well into 2028.
No, without a doubt. Because upgrading a fleet of 10,000 computers across a global enterprise is terrifyingly expensive and risky.
I can imagine.
If a company relies on a custom-built legacy piece of software that hasn't been updated in a decade, they will keep running the old OS just to keep that software alive.
Even if it means risking security vulnerabilities after the official support ends.
Exactly. The environment dictates the OS. We even see this geopolitically with the N edition of Windows in Europe.
Right, the N edition.
Yeah, due to European antitrust regulations, Microsoft had to release a version that completely strips out built-in media players.
That is so weird to think about.
It is. If you buy a PC in France, you might literally have to go download a specific media feature pack just to play certain video files out of the box.
Okay, let's unpack this next part, because looking at the different tiers of Windows, like Home, Pro, and Enterprise, the hardware limits are absolutely staggering.
Oh, they get wild.
Back in the 32-bit days, your computer was physically incapable of using more than 4 gigabytes of memory. On 64-bit Windows 11, the Home Edition maxes out at 128 gigabytes of RAM.
Right.
Windows Pro pushes that to 2 terabytes. And if you are running Windows Enterprise or Pro for workstations, the system will support up to 4 physical CPUs and an absurd 6 terabytes of RAM. Who on earth needs 6 terabytes of RAM?
Well, it sounds completely ridiculous for a standard user playing video games or, typing a document. But we have to zoom out to the enterprise scale. Think about a massive corporate data center. They use a technology called virtualization. Microsoft calls their version Hyper-V.
Right, Hyper-V.
Yeah, so instead of buying 50 separate physical computers for 50 different company tasks, they buy one absolute monster of a machine with 4 CPUs and 6 terabytes of RAM.
Oh, I see.
Then, the operating system uses Hyper-V to carve that physical hardware up into 50 virtual computers running simultaneously inside the main machine.
So they're all sharing that one massive pool of resources.
Exactly. And to pull that off, you need a monstrous pool of memory.
Wait, if a company has an enterprise machine storing 6 terabytes of incredibly sensitive data in its memory and drives, how on earth do they secure that? Like, if a thief literally breaks into the server room and physically steals the hard drives, does the open nature of Windows mean they just plug them in and read everything?
Well, no, and that is where the enterprise security features kick in, specifically regarding encryption and centralization. Windows 11 Home includes basic device encryption, where if something goes wrong, your recovery key is stored in your personal Microsoft account online.
Right, tied to your email.
Right. But in a corporate environment running Windows Pro or Enterprise, they use full BitLocker encryption. Every drive is scrambled. The only way to unscramble it is with keys that are securely stored and managed internally on the company's Active Directory server.
Active Directory is essentially the corporate bouncer, right?
Yeah, it's the bouncer, the security camera, and the rulebook all rolled into one.
Wow.
It is a centralized server that verifies the identity of every user and device on the network. If someone steals that encrypted hard drive without the Active Directory server verifying their credentials, the data is just cryptographic noise.
It's just junk.
Exactly. And Enterprise also gets tools like App Blocker, where the bouncer strictly dictates that employees can only run approved software.
Right, no installing random games on the work computer.
Exactly. And they have branch cache, which saves massive amounts of internet bandwidth by downloading a file once from headquarters and then quietly sharing it locally across the branch office's network.
That's super efficient.
It is. And they even run a totally different file system called ReFS, the Resilient File System.
I read about ReFS. It automatically verifies the integrity of data blocks, right?
Mm-hmm.
So if a cosmic ray or a power surge corrupts a tiny piece of a massive database, ReFS detects the corruption, quietly finds the clean backup copy it made and fixes the file before the user even knows there was a problem.
It's completely invisible to the user.
It's brilliant. But let's shift gears, because if Windows is this sprawling, chaotic public market requiring heavy-duty bouncers to keep it safe, Apple's macOS is an exclusive, pre-furnished gated community.
That is a perfect way to put it.
It is the definition of a walled garden.
The contrast in design philosophy couldn't be sharper. To continue your city analogy, Apple doesn't just manage the traffic. They own the roads, they build the cars, and they only let Apple-branded vehicles drive on their pavement.
Right.
macOS runs exclusively on Apple hardware. You cannot legally or easily buy an off-the-shelf motherboard and install macOS on it.
Right, so the direct result for the consumer is a much higher initial price tag, but the trade-off is incredible stability.
Exactly.
Because Apple makes the physical hardware, I mean, down to their own silicon chips now, and they write the software specifically for that hardware. They know exactly how every component will behave. I get it. You pay the premium at the Apple Store, so you don't spend 3 hours on a Saturday troubleshooting a bad third-party audio translator like we talked about with Windows.
Precisely. And the security landscape is also fundamentally different. The tight integration of hardware and software makes it inherently harder to exploit.
Because there's fewer variables.
Yeah. And add to that a smaller overall global market share compared to Windows, and it simply presents a less lucrative target for malware developers.
Okay, what I found genuinely wild in researching this is how macOS handles its file structure.
Oh yeah, it's totally different.
It is, because if you're coming from the Windows world, you are deeply conditioned to double-click a .x file to run a program. Or, dig into the C drive to find the program files folder.
Right.
None of that exists on a Mac. Instead of .x files, you download a .dmg file, which is a disk image. When you double-click it, the OS literally mounts it onto your desktop as if you just plugged in a physical USB drive.
It acts like a temporary drive.
You're right. But the application itself is the real magic trick.
You're talking about the .app bundle.
Here's where it gets really interesting. In macOS, an application looks like a single file with a .app extension. But it isn't a single file at all. It is actually a hidden folder.
Right.
I like to think of it as a digital bento box.
The bento box, I like that.
Yeah, because to the daily user, you just see the lid of the box, one clean single icon. But if you right-click that icon and select View Package Contents, you lift the lid off the bento box. Inside, you see all these perfectly compartmentalized folders containing the raw code, the graphical assets, the audio files, everything the application needs to function, neatly tucked inside.
And what's fascinating here is how that bento box design fundamentally changes system maintenance.
Oh, so?
Well, on Windows, installing software scatters files and registry keys all over the operating system.
Oh, right, yeah.
To remove it, you need a dedicated uninstall wizard to hunt down all those scattered pieces. But because of macOS's bundle design, to uninstall a program, you simply drag that single .app icon to the trash.
That's it?
That's it. You are throwing away the entire bento box in one fluid motion. I mean, there are rare exceptions for deeply integrated system tools, but generally it is just drag and drop.
But why build it that way? Why go through the effort to hide a folder behind an icon?
It all routes back to Apple's core design ethos, which is user experience above all else.
Okay.
Hiding the complexity of the file system empowers non-technical users. It removes the anxiety of accidentally deleting a crucial system file and breaking the computer.
Right, you can't break what you can't see.
Exactly. Apple simplifies the directory structure too. You have the Applications folder, the Untouched System folder where the OS lives, and the Library folder, which is hidden in the user's home directory.
Ah.
They hide the plumbing so you can just enjoy the water. And that philosophy is finally bleeding into the corporate world too.
Oh, really?
Yeah, Apple uses managed Apple IDs to allow mobile device managers to hook directly into a company's Windows Active Directory. So they're learning to play nice with the corporate bouncer so executives can use Macs on a Windows network.
So we have the chaotic public market of Windows and the gated community of Apple. But what happens when nobody actually owns the roads?
Ah, yeah.
That brings us to the open source frontier of Linux and the massive divide in the mobile world.
Linux is the great tech equalizer. It's an operating system where the underlying core, the kernel, is 100% free and maintained by thousands of volunteer developers and tech companies globally. It is the absolute definition of open source.
But you don't just go to a website and click download Linux. You have to choose a specific distribution or distro, right?
Right, because the core code is free for anyone to modify. Different groups take that Linux kernel and build their own custom operating systems around it.
So there are different versions for different things.
Exactly. Some distros are heavily fortified for running global banking servers. Others are incredibly lightweight, designed to revive a 20-year-old laptop. Some are even polished to look almost exactly like Windows for everyday desktop users.
But there is a massive catch. If my new bleeding-edge Wi-Fi card doesn't work on my Linux laptop, I can't call 1-800-LINE-UX for customer support.
No, definitely not.
I am essentially just hoping someone in a community forum got annoyed enough by the same problem to write a translator driver for it and post it online for free.
And that is the trade-off of total freedom. You hold total responsibility. You're the mechanic, the city planner, and the driver all at once.
And that open versus closed philosophy spills directly over into the computers in our pockets. The mobile divide is basically the desktop battle repeating itself on a smaller screen.
It really is.
Because on one side, you have Google Android. It's open source, based on the Linux kernel, maintained by the Open Handset Alliance. It runs on thousands of different hardware devices, from Samsung to Motorola. Anyone can build an Android phone.
Yep.
And if you want to write an app for Android, you can do it on a Windows PC, a Mac, or a Linux machine.
And completely opposite to that, you have Apple iOS and iPadOS. Strictly closed source, it only runs on the specific iPhone or iPad hardware that Apple manufactures.
See, this is the part that genuinely blew my mind. If you want to develop an application for the iPhone, you must use Apple's Software Developer Kit, or SDK. And that SDK features proprietary frameworks that are so tightly woven into Apple's architecture that it only runs on Mac OS.
That's right.
You literally have to purchase a Mac computer if you want to build software for an iPhone. And even then, Apple has to manually review and approve your code before anyone can download it.
Yeah.
Does that level of totalitarian control just completely stifle innovation, or does it guarantee a higher baseline of quality?
Well, if we connect this to the bigger picture, you're looking at the defining technological battle of our era.
Okay.
Open ecosystems foster rapid, messy innovation. When anyone can build anything without permission, you get incredible variety and rapid evolution.
Right.
But you also get a lot of junk software, hardware fragmentation, and severe security risks. Closed ecosystems sacrifice that Wild West innovation for a heavily curated, seamless, and highly secure user experience. It is the eternal tug-of-war between safety and freedom.
And we're seeing Apple flex that control to blur the lines between mobile and desktop with iPadOS. They've updated it to run a full desktop-class Safari browser, added real multitasking, and built in this feature called Sidecar, where the iPad seamlessly becomes a second wireless monitor for your Mac. The ecosystem lock-in is real.
It is very real. But while Apple and Microsoft are building heavier, more complex cities, Google is blurring a completely different line with Chrome OS.
Yeah, because we've spent this whole time dissecting these heavy, feature-rich operating systems. But what if you take the city planner, fire them, and just build a train station? That is Chrome OS.
It is the ultimate cloud minimalist approach. Under the hood, Chrome OS is actually based on the Linux kernel.
Oh, really?
Yeah, but Google stripped away almost all the local complexity and designed the entire interface around one single application, which is the Google Chrome web browser.
Wow. And because there is barely any local OS to run, the hardware requirements are incredibly low. It runs beautifully on cheap, low-power laptops, but the catch is huge.
Very huge.
It requires almost constant network connectivity. The applications don't live on your hard drive, they live in the cloud.
Yeah, if you lose your Wi-Fi connection, a Chrome OS device loses a vast majority of its functionality. It essentially becomes a very expensive paperweight.
But think about the massive headache it solves.
Oh, for sure.
With Windows, Mac, and Linux, we have this huge compatibility problem. You cannot take a windows.exe file and run it on a Mac. The code is written in different languages for different traffic cops.
Right.
But with Chrome OS, because every application runs inside the web browser, it completely bypasses the OS compatibility problem.
Exactly.
A web-based application doesn't care what the local hardware architecture is. It runs exactly the same, whether you open it on a 6-terabyte Windows workstation or a $200 Chromebook.
And this raises an important question for consumers because it represents a total paradigm shift in computing. For decades, the goal was to put a powerful processing engine on everyone's desk.
Right.
Chrome OS shifts the heavy lifting away from your local hardware entirely. The processing power isn't on your lap, it's on a server in a Google data center hundreds of miles away.
Wow.
That solves compatibility, but it introduces massive questions about data ownership and privacy when every keystroke relies on a corporate server to function.
That is a great point. But no matter which philosophy you buy into, Whether you manage a massive Windows server, enjoy the Apple walled garden, or carry a minimalist Chromebook, they all share one universal vulnerability.
Hmm.
They all require constant maintenance to survive. Software is never actually finished. It constantly decays.
Right. An operating system is not a static product you buy, install, and forget about. It is a living, breathing digital environment, and it's under constant attack.
The survival mechanics are fascinating. Backups are your ultimate safety net. macOS has a brilliantly simple tool called Time Machine.
Oh, Time Machine is great.
It really is. You plug in an external drive and it automatically takes hourly backups for the past 24 hours, daily backups for the past month, and weekly backups for all the months prior. When the drive eventually gets full, it just quietly deletes the oldest backups to make room for the new ones. It is a perfect set it and forget it mechanism.
It is. But a backup only saves you after disaster has occurred.
Right.
To prevent the disaster from happening in the first place, you need proactive updates. Updates are what patch the security flaws that attackers are constantly finding in the city's walls.
But updating an OS usually means a big, heavy download, tearing up the digital roads, and a long system restart where you can't use your computer.
Which nobody likes.
Exactly. But Apple introduced a really clever mechanism called Rapid Security Response, or RSR. It allows them to slide emergency critical security patches directly into the OS without a full restart.
It's like patching a pothole while the cars are still driving over it.
Yes. You can tell if your device received an RSR patch because they simply append a letter to the OS version number. And they use this across macOS, iOS, and iPadOS.
It is a strictly necessary evolution because the global threats are moving much faster than traditional monthly update cycles can handle. Users also have the option to opt into beta updates, where you can test upcoming, unreleased versions of the operating system.
Which seems like a terrible idea for most people.
Oh, absolutely.
Turning on beta updates means you are voluntarily signing up to be a crash test dummy for incomplete software.
Yeah, you are explicitly trading system stability for early access to new features. In a production business environment, you would never, ever run beta software on a critical machine.
Never. So what does this all mean? We've covered a massive spectrum of how technology handles the hardware we rely on. We started with Windows, the hardware-agnostic juggernaut that rules the enterprise world with massive memory limits and strict Active Directory bouncers, but struggles with chaotic third-party drivers.
Right.
We explored Apple's meticulously curated, highly secure, but fiercely controlled gated community with its bento box file structures. We looked at the completely free, wildly varied, do-it-yourself world of Linux and the Android-iOS divide. And we looked at the cloud-centric, lightweight approach of Chrome OS. But the one unifying truth across all of them is that you have to actively participate. Whether it's running Time Machine or allowing rapid security responses, you have to maintain the digital city to keep it safe.
You know, looking at all these different approaches side by side, particularly the Chrome OS model where everything is pushed to the web, leaves me with a final thought about where all this is heading.
Okay, what's that?
As our internet connections get faster, and as more of our heavy daily applications move entirely to the cloud, will the underlying operating system eventually become completely invisible and irrelevant to the average user?
Oh, wow.
Are we rapidly approaching a future where the device you buy is no longer a computer in the traditional sense, but just an empty pane of glass connecting you to an operating system that lives entirely in a corporate data center?
Wow, an empty pane of glass. That totally upends how we think about the expensive hardware sitting on our desks right now.
Yeah, it really does.
That is definitely something for all of us to mull over the next time we're staring impatiently at an update screen. Thanks for joining us on this exploration of the invisible bridge, everyone. Keep questioning the technology you use every single day, and we'll catch you on the next deep dive.